Hey everybody, tonight we have an unusual looking logarithm problem. I'm going to write down the relationship between logarithms and exponentials. In fact, this is more or less a definition. You can say log base b, and I like putting the parentheses, although it gets left out quite a bit. Log base b of a number x, and this doesn't say b to the x, it says log base b in the functional sense of x is equal to y, is equivalent to the corresponding exponential statement, which says b raised to the y is equal to x. Okay. Now, a lot of you may have been told it's not legal to have a base less than 1, but you can have a base less than 1. Consider log base 1/2. The base is 1/2. And we'll say the input argument's 1/8. And that is certainly equal to 3, since 1/2 cubed is equal to 1/8. Okay, just to let you know that critical thinking is allowed, and a lot of times you don't see logarithms that way, and you start believing there's no such thing. Totally legitimate. Okay, so now a lot of you who've done logarithms might think, well, we just need to use the properties of logarithms. In fact, you don't. In fact, that's the hardest way to do this problem. So what we do right here is just consider the base and its prime factorization. This doesn't take too long to discover. And so you see, based on this definition I showed you, we're just seeking a value of x such that 40 over 81 raised to the x is equal to this value over here that includes an irrational number. Okay? Again, it's very easy to dive into those properties of logarithms. It says the log of a product is the sum of the logs, or the log of a quotient is the difference of the logs. That would be the wrong way. It would get you there, but it'd be very tedious. It's very probable you make some sort of mistake along the way. Now, so let's move along. And you can see what I've done right here. My very first step here is to apply one of the rules of logarithms to the input argument, meaning you have to apply x to each of these guys right here, okay? And you can see that's exactly what I've done. Those are very well-known properties of exponentials, okay? And so that was all I did on this very first step. Now, and let's see what else. The very next step, what did we do right here? Nothing, I guess. Oh yeah, this step I just applied x to the input argument. Okay. Now, this next step involves just multiplying through by the reciprocal right here. You can see that the 3 to the 6 comes to the top, but that cancels out 6 from 3 to the 4x without talking about the rules too much. And in a similar fashion, if you bring 2 to the 4th underneath, that's equivalent to subtracting 4 from 3x, and similarly for 5x minus 1, okay? And again, that was accomplished simply by inverting this fraction and multiplying, and then applying laws of exponents, okay? Now, already we have some fairly good news right here. Notice that, let's just write this out over here on this side. Using exponential notation, which is quite convenient here, this is 3 to the 2/3, okay, times 5 to the 1/3. But we get kind of a free lunch here on this problem, and that's noticing that 2 is not present on the right-hand side, and yet we have 2 as a factor over here. Now, how do we resolve that? Well, there's a famous result, and a lot of people memorize it, but it's very easy to prove. Anything raised to the 0 is 1. It's an example of a common rule, a well-known rule that is memorized rather than understood. But it's very simple to prove that just from first principles. Think of 3 squared over 3 squared. That has to equal to 1, but then you would subtract 2 from 2 to get 3 to the 0. Okay? So there's a justification for that. So you see, we have no option here but to set 3x minus 4 equal to 0. And you'll see why that's an absolute necessity. Or this is necessarily true because there's no powers of 2 over here. So if you didn't do this, you would have some power of 2 over here, which you can't have. So you see, this really quickly gets us to x is equal to 4/3. Now you can check the others, but this is the answer. Now you may be thinking, well, you just got off easy. Yeah, you're right, I did. But you can verify. You can verify that this works for the case right here. This would give you 5 to the right here. Would give you 5 to the 1/3. Right, folks? And you can check the other one if you want. You would reverse the order of this since it would be a negative exponent. But you see, if you put 4/3 where the x is, you get 5/3, which is on the right-hand side. And it's the same thing. You can check it out by putting 4/3 right here and using the fact that a negative exponent would go to the top. Or you just flip around these factors, okay? But in any event, that is the answer, okay? X equals 4/3 is the answer. We are done. And I like this problem quite a bit because it's highly tempting to try to use properties of logarithms rather than just revert back to the definition. So this is equal to 4/3. All right, talk to you next time.